got up to this problem in the review sheet. So I did the ones before it. So if you want to watch that video, go watch it. Okay? If we finish, we'll go back to that, but I don't think we will. So vector mathematics. The one prior I did graphically. Remember, you could do them graphically with a scale and a protractor and a ruler. But we don't know how to do them mathematically as well. So it says here that Brady runs 10 meters at an angle of plus 20 degrees to the x-axis. We'll call that A. And he then runs 20 meters at an angle of plus 65 degrees to the x-axis. We'll call that B. Draw a representative sketch of his short stint. So A looks like that, 20 degrees, and then 20 meters was B. That was 65 degrees, right? Like so. And A was equal to 10 meters. And B was equal to 20 meters. And then it says, mathematically calculate the x and y components of the first leg of his journey. So if I was to draw those components on my little sketch here, how would I draw those? Jack? Okay. So we're going to make a right triangle, that's right, with AX and AY. Like so, right? So part 2, we're going to use our formulas for AX and AY. And who wants to tell me what the formula for AX is? Okay, so AX, which is also a vector, is A cos theta, which will be 10 meters times the cosine of 20 degrees. So you might want to have your calculator out to make sure it's in the right degrees and all that. So you set 9.4 meters. And then AY, what's the formula for AY? Who wants to tell me that? Kelly? Which other one? That's okay, that's your the review packets. These are review packets. So that packet that you have there, that would explain it. I posted those online as well. Yeah. Yeah. Well, now you got them. All right. Well, now I only have the multiple choice. All right. Is there anyone else who doesn't have one? Wish you all would be more like Jack and Michael. Well, those two are your proteges, so it's just assumed. I'm just kidding. All right, now Oh, the other thing was your formula sheet. You can bring that in with formulas only written on it, right? Like always. AY is equal to what? A sine theta, 10 meters, sine of 20, random guess, let's see. 3.4, wow, that's amazing. I think he cheated. If I was to draw the components, number 3 says mathematically find the components for x and y of the second leg of the journey. How would I go about doing that? If I was to draw them in there first. Let's do that. Lizzie? Bx by, and then similarly, bx will be 20 meters cosine 65 degrees, and by is 20 meters sine of 65 degrees. Did I do that right? My brain is elsewhere. I'm getting a cold. 8.5 meters, 18.1 meters. And then part 4 says to find the components of C, which equals A plus B, the vectors A plus B. That is, find Cx and Cy. So Cx will be what? Yeah, because you see, it's going to be the Ax plus the Bx, right? Not Ax plus Ay. Ax plus Bx. And then Ay plus By will be the other Cy. So Cx is Ax plus Bx, which Ax is 9.4 meters plus, oh man, 8.5 meters. What did you say it was? Okay, and then Cy, similarly, is 3.4 meters plus 18.1 meters, which is 21.5 meters. Okay. Part 5 says find the magnitude and direction of C. Okay. Well, Cx is this, right? When you add Ax plus Bx. And if I was to draw Cy on there, it's that. So what, if this is Cx and that's Cy, what's C going to look like? Like that, right? Put that on in purple, like so. So there's our C. And it skipped us. All right, so C, the magnitude of C, right? Remember the bars mean magnitude like that? It doesn't really matter, but cx squared plus cy squared, which equals 17.9 meters squared plus 21.5 meters squared. Now we can calculate that. Okay, so $28. Wow, you're magnificent. So that's the magnitude. How do we get direction of C? We'll do the tan inverse, right? Cy over Cx. 21.5 over 17.9. 53 degrees, isn't it? No. 50.2 degrees. So we could see our C here, and its length was, man, 28 meters at an angle of 50.2 degrees. Hello, welcome. Okay. That seemed pretty clear? Yeah. All right. Oh, the result, good. Well, there's a lot of you. Do you have seats? Okay, good. This is a freshman physics class. We have exams next week, so we're in review mode right now. We're getting ready for those. So we study, although it's freshman physics, we still study physics in classical mechanics. And later in the year, we get into waves, and electricity, and magnetism, energy. So that's basically what we're doing now, getting ready for our exam. Okay, let's move on. All right, so this goes way back, right, to the beginning of the year, and just plotting up variables and coming up with various things with them. So let me add the second half of that on. All right, so the first thing we'll do is plot this data up. And our time is going to go on which axis? Bottom one, or the x one, and then distance on the y. And since we go from 0 to 0.8 and on the x, 0 to 0.8, how should I arrange that, you think? Well, if I go by 3, that's going to be, well, because it's nice to have like divisions like 0.1, 0.2 for each line, right? So we'll stick it like that's 0.2, 0.4, So the main thing is we want to use a good part of our graph, right, on there. And we know from lab that what else do we need for the axes? Okay, so we need units and also what the variable is that we have down there, so time. And then distance we'll put on our y, and we go up to 30. So let's do 10, 20, 30. I probably could have extended it, but that's okay. And that's distance over here. What's our symbol for distance? S, right? Or position is S, and the distance is change in S. And time is T. And now we'll plot the data on there. So 0, 30, 0.2, 25, 0.4, 19, 0.6, 16, and 0.8, 10. And I cut it off, but number 1 said to plot the data and things like that. So 2 says to draw the best fit line for the data and compute the slope. What do the units of the slope describe physically? So if I put the line on here, Lorena, how will I go about doing that? Do I just connect the points? It has to be straight, right? So we could get a ruler. Yours would probably be a little easier to control, right? I'll have rulers actually for the exam, so you don't have to worry about bringing that in if you forget yours. So does that go through every data point? No, it doesn't. Okay, thanks for coming for your short visit. No, it doesn't. It misses some of them, right? So this means we have to be careful then when we go about calculating the slope. So one of the big mistakes is like you would take 2 points like these two. If we take 2 data points and calculate the slope from it, pay attention because this is important. Don't worry so much about that. That would give you a slope going off like that, right? Right. So we need points on the, and it doesn't have, you could choose points if you actually have points that fall on them, but it could be that none of your points actually fall on the line. So you have to pick points that are not on there. So let's do it like that. Just, I'll pick this point right here. It's not that actual point, is it? And this, well, I'll pick the one right there too, because that's the easiest. So get this out of the way. So draw a best fit line for the data. What are the units of the slope? And compute the slope. Let's compute that first. So the slope is change in y over change in x. y2 minus y1 over x2 minus x1. We have more. Okay, so what's our y2? Well, if I label this point here, the green one, not the blue one, then that point on there is going to be what? What do you think? Courtney, you want to give it a whirl? 0.615. And this 0.6 is in seconds, and the 15 is in meters. And then how about this point here? Hannah, you want to tell me that one? 0.30. Okay. How are you folks? I'm Mr. Ring. I'm a physics teacher here. I also teach environmental and I teach geology. Right now um, we're reviewing. We have an exam next week. They have exams in all their classes next week. This is a freshman physics class, so we've done things like velocity and acceleration, forces, um, and the like, and projectile motion, motion in one dimension, motion in two dimensions. And so we're just reviewing and going over something that we did right at the beginning of the year um, at the current moment and getting ready for their exams. Okay, so we chose our points, and now we can just plug those in. And what was Y2? Yes. No. As long as you're consistent, you can't use, your X2 has to go with your Y2. Your X1 has to go with your Y1. What was Y2? Well, I'll go with 30. I mean, it's either way. You could use either point. Just have to be consistent. So if we use 30 meters, right, then we're saying that goes up there with that one. So 30 minus 15. And then in our X, we have 0 minus zero point 0.6. So you can see that the Y2 and X2 go together, right? 0, 30, 0, 30, and likewise for the other one. So 15 meters over minus zero point 0.6 seconds gives what? Minus 25. What are the units? Meters per second. Okay, does it make sense? A good check if we use x2 and y1 and all that correctly is if it makes sense. Is the negative slope make sense here? Yeah, we're going downhill. Okay, the next part says, what do the units physically or describe physically? Okay, so with the negative, probably we would say what? Velocity. It's giving us some indication of direction. And, okay. And of course, now we know that, right? It's pretty simple. But back then we hadn't even started to learn too much about speed or velocity yet. What is the y-intercept for the data? Well, what is it on there, Sam? You want to tell me? 30 what? What are the units? 30 meters, right? So our B is 30 meters. And write out the equation using t for time and s for distance. So if we did that, we would have s equals, so it's just, we're going to relate it right to what we're all used to from math class, mx plus b, where s equals, what's our m? Negative 25 meters per second. And x would be t, and then b would be plus 30 meters. And then the question wasn't asked here, but we talked about interpolation and extrapolation, and we could interpolate with t's in the range of what? Point, yeah, or 0 to point 0.8 in there, and then extrapolate out to other t's. Yes. Yeah. If you plugged in 2 points, then you have the equation y minus y1 equals mx minus x1, right? You could do that. you'll be able, in this class, you can get it off of the graph, okay? What would you say is a good title for this? Yeah, so, I don't know, velocity calculations. Okay, moving on. Okay, this problem brings up a little bit of like what notation is and things like that. So it says at the beginning of its motion, an object has a speed of 5 meters per second. 5 seconds later, the speed is minus 10. Compute delta V bar and, or no, that's delta V. It's a little hard to read on here. And then V bar. Thank you for coming. Bye-bye. So to get delta V, it's what? The change, right? We've done this 100 times now, so we'll just go quickly through it. 5 meters per second. The speed of the object. Oh, wait, no, I didn't do that right. Distracted. What's VF? Negative 10 meters per second minus 5 meters per second equals, okay. And then the other thing, which looks like average, right, would be minus 10 meters per second plus 5 meters per second over 2. What? Negative 2.5. Usually I would have you review, tell them what we're doing and stuff, but we're sort of in the middle of review, so I think they saw how smart you all were. I guess so. All right, let's move on. Well, we're going to get there, but all right, let me do this one, and then I'll skip to the next page. And then I'll have to remember where to come back to, but that's all right. Okay, when the trigger's pulled, a bullet accelerates down the barrel of a 1.15 meter long gun. Good thing we weren't doing this one. And comes out with a speed of 350 meters per second. So the bullet like starts here. Comes out over here. Oh, a little darker. Oh, boy. Yeah, tricks of the trade. Teacher school. But they haven't taught me how to juggle the things yet. Like juggle like stuff like this. I guess I have to teach myself. So the distance here equals 1.15 meters. What else do I have that I could add to my sketch? VF, which is 350 meters per second, and VI is 0 meters per second. You know what I should have done with the parents is make sure we were doing like trig when they come in, then it would be impressive because it says things they don't understand, like sine and cosine. Say, oh, do you see that stuff? What was that? I remember doing something like that in high school. All right, being silly. And this is 1.15 meters. Oh, my A, we know A, right? It's minus 10, right? No, it's not, is it? Right? So, so you have to be careful because students do that all the time, right? They'll plug in minus 10, and it's not under the acceleration due to gravity. It is, but we'll assume it's just being balanced, like by the support force of the gun. So we want to know how long it's in the inside the gun. Find that out. So the average is just 2 added together divided by 2, 175. Delta V is that minus that, or 350. Now what am I going to do? How do I get delta T? Yeah, well, V bar is delta S over delta T, right? So delta T is delta S over V bar. And delta S is 1.15 meters. And V bar is 175 meters per second. Point 00657 seconds. And then A is simply delta V over delta T, 350 meters per second over 0.00657 seconds. 53,261 approximately meters per second squared. Man, my nose keeps running. Yeah. We've done so many of them that you know them pretty well. Okay, moving on. You wanted one from the next page? So, this thing? All right. Oh, sorry. What's the... Okay, compute the acceleration of the ride and the displacement in each interval. So velocity versus time. It says each block is 5, so 5, 10, 15, 20, 25, 30, 35, 40 in meters per second. And this is just 1, 2, 3, 4. Right? How do I get acceleration from a velocity versus time graph? Very. The slope, right? There's change in V, change in Y over change in X. In this case, change in V over change in T. That is the acceleration, right? So, you know, we can use these values of like VI is 0 and VS up here is 30 and delta T is 3 seconds and put it in an RGC, and we would get the same acceleration as if we got the slope, right? Acceleration is the slope. Didn't you listen to what I just said? All right. Oh, all right. Sorry. That wasn't very nice. So we could get the slope relatively easy here, right? The change in y would be 30, and the change in x would be 3. So my initial slope in A is 10 meters per second squared. For B, it's what? A is 0 meters per second squared. For C, A is a change of 30 over 1, 2, 3, 4. 30 divided by, no, is it? It's just sort of messed up. 1, 2, 3, 4. 30 divided by 4 is 7.5, and it's negative. Does that make sense? Well, you might have both. Or one, or none. Does that help? Well, I'm spending time to go over both of them. That was fast. How do I get displacement? The area under the curve, right? All right, I'll start off C block with this problem, finish it, to watch the videos. This will be 2, and the one with C block will be 3.